Hi, I'm Bob LoMastro, and here's my instructions on how to build the hairdryer demo for safety training. I better start with a standard waiver of responsibility. This is a live demonstration using electricity and water, which can be a dangerous combination if it's not done correctly and safely. The purpose of the demonstration is to illustrate the difference between overcurrent protection and GFCI protection. The point being that overcurrent protection is designed to protect the equipment and the facilities from getting too hot and starting a fire. GFCI protection is designed to protect people. If current is running through the person, then it's obviously not running through the intended path. The GFCI recognizes that failure and shuts things down. Watch the video and you'll see how this demonstration is performed. And you'll notice that we have a lot of fun while we're teaching. What will happen if I accidentally drop it in the water?
I heard somebody
Let's find out. I heard him say trip the breaker. Let's find out. Are you ready? What'll happen is I'll turn it from an air pump to a water pump. Now, those of you who are thinking trip the breaker, what causes this to trip? Heat. It's running cooler today than it ever has before. It's liquid filled. Now, if you come over and test it, the water's energized. If Chuck reaches in there to rescue that hairdryer, he's going to do the tango. So, how many of you thought this was being protected by this device? Did you test it? No, you did not. What we're going to do is we're going to test it with the hairdryer. What will happen if I plug this into the GFI? What will happen now? Huh? It's like that, right? Oh, it didn't work. I hate it when that happens. I know the GFI is not imbalanced right now. All the power that's going into that tank, it can swim for a while, but the completed circuit needs back to the GFI. It's not unhappy. We need to bring Chuck back up. We're going to have Chuck grab a grounded surface here and then stick his hand in the water. Let some of the current go that way home. It should trip our GFI. It was should that got you though, right? All right, all right. So what we'll do is we'll use the other Chuck. I'll ground this wire.
I heard Jason volunteer. Remember?
I'll violate Chuck. And we should trip the GFI in a fifth of a second. This Chuck's a little limp. Just fell right off of it. Now, here's the point with the GFIs, folks. They are there to protect you. They function in a fifth of a second. A circuit breaker will delay 2 to 3 seconds and up to 5 seconds, depending on the short, because of its design. It's designed to allow for motor starting. GFIs work. The problem is when they trip, people get pissed at the GFI. How silly is that? It's doing exactly what it was designed to do. When these trip, something's wrong. These can go bad. The cord can be bad. The tool can be bad. But something's broke. I'm sure this will surprise you, but we do sell an advanced model kit. It costs $1,500, but it comes complete. Instead of the hairdryer, we use an air pump with this kit, as you see as we go along. It's a little bit simpler for the first-time users. Now, you certainly can build your own, and we'll walk you through the process. Keep it simple, but keep it safe. Okay, let's go through some of our basic materials. We start out with a clear tub. You can use Rubbermaid or Tupperware, something that's large enough for your hairdryer to lay down completely in. You're going to need a ground wire, something that we can cause a loss of power from the hairdryer through the water. I buy cheap hairdryers, but I want one with a cool button, some way I can turn off the heat coil. It just gets in the way and it causes your hairdryer to fail quicker. You'll want a power strip with 2 or more receptacles, a portable GFI, And it's nice to have a voltage detector to illustrate that while the hairdryer is running in the water, that the water itself is fully energized. The first step is to fill your water tank deep enough so that the hairdryer will be fully submerged. You don't need to use any specialized or demineralized water. Regular tap water will be just fine. Okay, the next step is to prepare your hairdryer. As I said earlier, I like to buy hairdryers that have a cool shot or a cool button, or a switch that allows me to turn the heat coil off. The heat coil is just something that's going to fail early. We don't use it at all in the demonstration. Your hairdryer will come with a GFI built in. Now I like to remove mine and put a standard plug on the end, but that's optional. That's entirely up to you. And another option, instead of the hairdryer, I go to Target and I buy air pumps that they use to fill air mattresses. They cost anywhere from $13 to maybe $15. The problem with the air pumps, they work great, except they throw water 15 feet across the classroom if you're not careful when you drop it in. Okay, now we're ready to prepare our power supply. Again, the easy way is to use a power strip. And then I take my alligator clip and I stick one end to the ground on a receptacle. And this is used to create the loss of power necessary to trip the GFI. Sometimes, because I'm a joker, I'll stick a hot dog on the other end so that the hot dog actually enters the water and simulates a human sticking their hand in it. You're ready to power up your hairdryer. Once again, you should have turned off your heat coil, either tape down the cool button or turn it to a fan-only setting. Your ground wire is ready to go, and your hairdryer is now ready to be dropped into the water tank. Okay, here's the part you have to practice. You have to have your spiel set. I turn on the hairdryer and I ask the audience, okay, what'll happen if I accidentally throw this in the water? The common response is the circuit breaker will trip. But it won't. It'll keep running because the circuit breaker isn't pulling or allowing more current to flow through. It doesn't overheat. There's no reason a circuit breaker or a fuse would blow. Now pay attention. You don't want to reach in the water for the hairdryer. Turn the power strip off and unplug the hairdryer before you remove it from the water. Now we're ready to demonstrate how the GFI works. So if you have a portable GFI, plug it into the power strip, or if you're using the GFI on the hairdryer, that'll be sufficient. You've got your ground wire connected to a ground port on the power strip, and if you use the hot dog, go ahead and violate the hot dog at this point. When the wire or when the hot dog and the wire touch the water, an alternate path for current exists and it cheats the GFI. It should trip in 1/5 of a second. Once again, don't forget, the tank is energized. Don't touch the water. Okay, just a couple of final thoughts. Practice, practice, practice. Get your spiel down. Have some fun with it. Always test the GFI before you start the class. Like anything else, GFIs can fail. And I know I'm repeating myself, but don't touch the energized water. This is 120 volts at likely 20 amps. That's 20,000 milliamps. And technically, that could kill up to 200 people. Have fun and watch them learn. Now, if you're going to do this demonstration a lot, it's probably in your best interest to create a display board to hold a receptacle and a GFCI receptacle. You can also include a ground port, an access for easy ground connection. Whatever you do, use a watertight connection to your box. Use a watertight box. This is obviously going to be used in a wet location. I've been safely performing this demonstration in the classroom for over 25 years, but it still amazes me the look on people's face when the hairdryer keeps running and when they realize how the GFCI trips immediately when current would be exposing them to danger.